So we've spent a lot of time looking at reflection and mirrors, so now we're going to start to move on to kind of the next property that we want to study for a little bit, and this is going to be with refraction. And refraction is something that you have noticed quite a bit, maybe not by name, but you've certainly noticed it. So like for example, we have this pencil in the water. If we kind of look at it, it looks like the pencil's bent, but the pencil itself is not actually bending. What happens to be bending is the light rays that are reaching your eyes. When they go from the water to the air, those light rays are going to change direction, and then we interpret that as sort of, it looks like the pencil's bending, but it's not actually. Kind of same thing, if you're in a pool and you drop something on the bottom of the pool, where you look to try and grab it is not actually where the location of that object is. Once again, it happens to do with that bending of light. So this change in direction of light, this is referred to as refraction. And this happens because of the change in speed that light experiences when it passes from one medium to another. So like from air to water, oil to air, so on and so forth. So kind of looking at just a basic ray diagram, what we've looked at so far is we've kind of looked at an incident and a reflected ray. So we have that angle of incidence and that angle of reflection taken relative to the normal. What we're going to introduce now is we have a medium 1, we'll say. So this is medium 1 and this is medium 2. So for most cases, whenever we have light hitting a surface, depending on the type of medium that the light's going into, you're going to have light that is reflected, consistent with the law of reflection, but some of that light is going to pass through into a new medium. So what we're going to have in here is we're going to have this refracted ray. So this is the light ray that passes into the new medium. It's going to change direction, and it's going to have this angle of refraction also measured relative to the normal. So again, it's really important that we take those angle measurements relative to the normal, especially when we start doing the mathematics. Now, the question that gets asked quite a bit is, how much is that light going to bend? Well, that is going to depend on something that we call this index of refraction. So let's have a look at that. So the index of refraction, refractive index if you so please, it's sort of a measure of how much light's going to slow down when it's not traveling in a vacuum. Because when we talked about the speed of light being 3.00 times 10 to the 8 meters per second, that is the speed of light in a vacuum. When it's not in a vacuum, we have to be a little bit more careful. So in other media that's not a vacuum, light is going to slow down. Now, it's not going to slow down where it's going to go from like 300,000 kilometers per second to like 50 kilometers per hour kind of thing. Like, it's still going to go relatively fast, but the measure of the index of refraction, it's just going to be the speed of light in the medium, the speed of light in vacuum divided by the speed of light in this non-vacuum medium. So what we're going to get is we're going to get this number with no units called the index of refraction. So for our purposes in Physics 30, index of refraction is going to be a number that's greater than or equal to 1. If the index of refraction is 1, we're dealing with a vacuum or air, as I'll talk about in a minute. And then greater than 1, we're dealing with kind of non-vacuum, non-air mediums. Now, this equation is not on the data sheet. We'll show you a trick to get that a little bit later. Now, the other question that comes along is, how much does light bend? We already talked about, and we'll look at that index of refraction. But we want to know whether light's going to bend towards the normal or if it's going to bend away from the normal. So the rule for that is if we have light, it's traveling from a medium of low refractive index to one of higher index of refraction, so we're going from low to high, we're going to find that the light refracts towards the normal, or it's going to bend towards that normal. So the angle of refraction is going to be less than the angle of incidence. Now, same time, if the light, or the opposite to that, if the light's traveling from a medium with a high refractive index to one that is lower, we're going to find that light refracts away from the normal. So that angle of refraction is going to be greater than the angle of incidence. I'm going to put a star next to this because this is the incomplete story for the second case. There's a little bit more that we want to talk about with respect to that, but we're going to come back to that a little bit later. So I just have some diagrams here showing like the speed decreasing. So if we're going from a low to high medium, so with the speed decreasing, we're going to notice that ray bending closer to the normal. Whereas in the second case, if we have the speed increasing as we transverse mediums, so we have going from a higher index to a lower index, let me rephrase that again. So sorry, in the first medium here, sorry, the speed's going to decrease. We're going from a low to a high medium, and then in this case here, we're going to have a high to low. Sorry, I had that right. I just tripped over my own thoughts. Sorry about that. So yeah, in this case, we're going from a medium of high index to low index. So in that case, when we go to the lower index, the light is going to speed up. And when it speeds up, we're going to notice that that angle of refraction is a little bit larger. So this is certainly important to note. The other thing is when we're talking about indices of refraction, usually when we quote, like say, oh, the index of refraction is 1.24 or 1.33, that's usually quoted for a specific wavelength of light. So if you're doing any experiments around indices of refraction, you certainly would like to talk about what wavelength of light that you're using. The last little point is the index of refraction of vacuum is going to be 1, like exactly. For air, you're going to notice it's about 1.0003. So there's a difference in that fourth decimal place. For us in Physics 30, we don't need that level of precision. So what we're just going to say is that the index of refraction for the vacuum and for air, we're just going to call that 1.00. So we're not going to worry about that slight difference. So we're going to assume the speed of light in vacuum and in air is 3.00 times 10 to the 8 meters per second.